Okay, so with this question, we've got a rectangle with a perimeter of 32. Okay, so I'm going to do a rectangle here. Let's call the width is x and the height is y. You can call length or width. Okay, so what we've got is perimeter is 32. So we're going to use that information, right? So the perimeter of a rectangle, which is 32, which is given to us, can be formed by multiplying the 2x plus 2y. Okay, so that's the first piece of information we have from the question. Now the question says prove that the maximum possible area. Now we are talking of area here. So area of this rectangle can be given by x times y. Okay, now if you want to find out the maximum possible area, then we know that at the maximum area your dA by dx would be equal to 0. So what we want to now do is differentiate this equation here. Okay, now to do that I would have to make all the terms in terms of x. So I'll use the information in, say, equation number 1 here, rearrange it to make y the subject of the formula. So what I get is 32 minus 2x over 2 equals y. Okay, that can further be simplified to 16 minus 2x equals y, and I'm going to sub that y in here. So the area which I get is x times y, which now happens to be x times 16 minus x. Sorry, I've made a mistake here. That's just a 16 minus x. Okay, right. So area expression, the area of the expression of the area is now 16x minus x squared, and now we can differentiate this. So differentiation of this equals 16 minus 2x. Now if I was to equate this area to be maximum, we know that dA by dx would be equal to 0. So that gives me 2x equals 16. So x is 8. Now there are two ways of going from here. The first thing what we can do is, whilst we have differentiated, let's just continue and differentiate again, just to show that the area that we are getting is the maximum, and then we'll prove that that area is 64. So the second differentiation is equal to the differentiation of that term basically is minus 2. Now since the second differentiation is less than 0, we know that the area is maximum, and that maximum area is nothing but, if you put the x value which we just got in the original area equation, which is this at the top over here, right? So if I put the area in here, what I can see is area turns out to be x, which is 8 times 16 minus 8, which is 8 again, is 64. So we've showed that the maximum area is 64 centimeters squared, and also that this area is maximum by doing the second differentiation. I hope that makes sense.